And yeah, for our first speaker, the battery recycling is an important step, and it is talked a lot about it. But recycling actually should be the last step in the life of a battery, since it's expensive and so on. Repairing can be easy and it can be cheap if it's done right. And with this, I want to welcome our first speaker, Felix Hornung. He is the co-founder of the medimobility, and he's an expert for battery repair. Felix, I'm really happy you're here, and the next 4 minutes are yours.
medimobility is a company which is specialized on battery repairs and battery maintenance. Where is it coming from? I mean, I don't need to tell this audience that there is an increasing hunger for energy and that batteries are a very hot topic at the moment, not only in the area of mobility, but also stability of our nets and also other applications like bicycles and so on. The number of batteries which are produced in this world is significantly increasing over the last years. So in 2023, the last reliable number was published with 10 to 15 billion cells, which is then roughly 200 to 300 million battery packs if we, for example, would take a bicycle or a scooter as an application. So obviously, this makes a huge amount of batteries which are entering our market every year, but repairs are not really done at the moment. And this has reasons. And the reasons are that they are firstly technically complex. You also need the spare parts, you need the know-how from the producer, from the BMS, from the CAN system. They are partially dangerous because you sometimes get batteries where you do not know which health status the respective battery is in. And obviously, the guys who are currently selling 200 or 300 million batteries or battery packs per year, they would like to also sell this amount of battery packs next year. And if you start now repairing these battery packs, their business model is in a certain danger. So as a result and as a consequence, we observed two situations. First of all, we observed that in the DACH region, so in Switzerland, Germany, and Austria, there is a certain lack of repair shops in the south. We observed that Netherlands is quite straightforward when it comes to repairs, and also in northern Germany, we observed a lot of repair shops, but South Germany, and we are sitting in Munich. I have to say this maybe in a side sentence. There was not really an offer for the customer to repair the batteries. And secondly, also the European Union recognized that there is a limited amount of repairs ongoing, while the battery materials and the waste the materials are very expensive and rare. The waste is a problem. So the European Union reacted with regulation. And the one regulation I would like to mention is the battery regulation. Obviously, the battery regulation is way more than the 3 bullets I'm outlining here, but the 3 bullets I'm outlining here are very important for our repair business. And the first one is that a battery pack must be easily removable and replaceable. That it has to be available at least for 5 years after the last model was sold, and most importantly, software must not prevent from replacing and also repairing the battery. That is very important for us. Additionally, the European Union also brought to life the Right to Repair Directive. This is now active, but has to be translated into national law until mid of next year. So we do not see the effects yet in the market, but there is a lot of discussions ongoing, which is going, when it comes to repair, obviously a little bit more or far than the battery regulation, saying even that the producer of a battery must offer a repair if the customer insists on it. And this is very important for us as a repair shop. Plus, it also obliges the producers to offer spare parts, tool instructions, etc. to repair shops like ours, and thereby enable repairments of batteries in the European Union. And this is exactly what medimobility does. here in Munich in our workshop, we are repairing batteries every day. This is not a vision. This is something we do. I saw in our system that we are at battery 2010, I think, something like that at the moment this year. So we are repairing every day, every month, hundreds of batteries, and thereby looking into maybe 4 different repairs. The first one is the damaged BMS. This is something which is very, very nicely to repair because the BMS is a board which usually is not very expensive, can be easily replaced, and is really saving the whole battery. And normally it is only a very small part of the material price of the battery, and thereby it's a very good business case for the battery owner to replace that, or for the person who gives the warranty for this battery, so the producer. The second one is the cell replacement. The cell replacement is at the heart of the battery repair, because you really have to replace all the cells. It's sometimes, especially if the batteries are coming from China, it's economically a stretch. So there we always need to investigate if it makes sense or if it doesn't make sense, but especially for applications where the batteries are not available as new products any longer in the market. Those cell replacements can not only save the battery, but the whole application. Then we see a lot of adapter damages similar to the BMS. This is a very straightforward repair and safeguards a huge value in material, but also in value for the customer. And finally, we also see often defective cases because they are dropped or something like that. So to keep them safe from water or other things dropping into the battery, we are also replacing the whole cases. That is what we do. I thank you very much that I had a chance to speak in front of you, and I think, Maximilian, that I have now another 4 minutes where questions can be raised if there are questions.
Yeah, thank you, Felix, very much. 4 minutes are over soon. You took a little bit longer, but I think we still have time for at least one question. If there's one in the audience, just raise your hand, unmute yourself, or write the question in the chat, and then I can ask it to Felix. Otherwise, Felix, maybe the right to repair, it sounds like it is a really important step. Could you maybe comment how well are the cell manufacturers or the product manufacturers prepared to fulfill this right, which is coming next year?
Yes, sure. Thank you very much for this question. So normally I would hand over this question to my colleague Christian, who is also on the call, and he's a lawyer who is specialized exactly on these kind of directives. But in this case, as we are on a time pressure, I try to answer directly. And the answer is pretty much straightforward. They are very, very rarely prepared. So especially if you come to the German producers, not even the ones which are outside of the European Union, but the German producers, especially the big ones, BMZ, Bosch, I personally have the feeling that those companies are still looking to see how the right to repair directive is then actually translated into German law and what it then actually means for them. And they are not taking preparation steps up front to prepare being ready in July next year, but they are waiting to see the final regulation that in Germany and then they will take action, which is a little bit a stretch for companies like us.
All right. Thank you, Felix, very much. And yeah, I think it's an important question, and we also planning to a deep dive session with your company, with your colleague Christian, to explore this further. But I think with this, thank you very much for your pitch, and I hand over to Simon and the next speaker.
Yes.
Thank you very much.
And also, yeah, thank you very much, Felix, for your talk. We now go up the value stream a little bit. We were talking about PowerCo before, right? And about cell manufacturing. And I want to come to the almost very first step, not the very first, but one of the first, and that is the battery coating. And want to introduce Clemens Disch to you, who's a marketing and sales manager at Werner Mathis. So on this expedition, I've seen many pilot lines, and if you look closely, you see many of their lines being installed there. And Clemens, I think, without further ado, it's time for you to explain what you do exactly and what the competence is you deliver in this field. So the stage is yours.
Thank you very much, Simon. Mathis is a small company, privately owned in Switzerland. We are making R&D pilot scale machines, sometimes small megawatt machines. And obviously, coating and drying is one very important part of the whole process. However, the step before, it's the mixing of the slurry. If it's anode or cathode, it's a very important part of the battery, and also a very important part for our machinery, so we can coat correctly the anode and the cathode. So therefore, the mixing is extremely important. We all know we have dry mix, wet mix. We can have batch mix. We can have extrusion mix. We got 𝗕𝘁𝘁 for the extrusion mixing. We got 𝗕rych for the batch mixing, and others. But also, what is also very important is how to store the material before you mix it, under which conditions you do that. So that's we see it very often that if the slurry mix is not really well, then we cannot coat correctly, and at the far end of the line of the battery, then the battery performance is not what is being expected and being calculated. So mixing, very, very important. I don't know, we'll go into more details on that one. We all know mixing is a key part of the battery performance. Then how do we coat? Coating is one of the, it's an art, I call it. Coating is an art. We can have a slot die. We can have an 𝗕𝘁𝗿𝗶𝗴𝗵𝘁 coating. We have the pump card where we have the vessel with the slurry inside. We can put nitrogen on it. We have the snake pump and then some filters, making sure that we only get the particles through which are specified, and then it goes to the coating head as a single layer coating or double layer coating. In this case, we're working with 𝗕𝘁 one of the most famous slot die manufacturers worldwide. And then obviously we need to control the coat weight, wet and dry. We're using in this case very often an X-ray unit from Scantech, which is then getting the signals back to us. So we have a closed loop system in order to make sure that the coat weight of wet or later on dry is achieved correctly. There are some measurements we can put in. For example, heavy edge we can install. We also can install A to B side alignment. So when you do the second side coating, that the second side is aligned with the A side. It's all possible. We also can install laser marking inspection systems. It's just to name a few of what is possible on the coating lines. And then the other thing is drying. Obviously, drying is also a very key part of the process. We can't dry too quickly. We shouldn't dry too fast. We shouldn't dry too slow. We need to bring in correct heat into the anode or cathode. We can use the convection. We can use IR laser. Also a combination of the both, or 3 or 4 is also possible, in order just to have a cost-effective drying process, because we all know the convection drying process can be expensive depending where you are in the world and what kind of electrical rates you have to pay for the process or for the plant. So just to summarize, yes, coating is an art. The mixing is also a very, very important part of it. You need to have the right chef koch for it. And if you have the right people working together with the right equipment, you get out what you want at the end, a well-performed battery.
Okay, Clemens, thank you very much for your pitch. Is there a question from the audience? Before I cannot hold myself and ask you questions. you know, the critical thing right now is to really scale up the process. Maybe you can elaborate and inform our audience quickly about where are the challenges in this coating? I mean, the coating is done for producing the electrode, right? So it has an electrochemical function. Where do you see the challenges that may hinder European companies to really succeed and be quick in entering the market at the moment? If you wouldn't name one or two examples.
That's a very, very good question. And I think one of those questions I did answer in our interview at the battery show in Stuttgart. The fine detail now is what we need. You know, we need to tweak many different screws to get to where we are, and we need to work together. And at the moment, everybody's trying to cook their own soup, and I think this has to stop. And we need to make one big soup in Europe to survive, and to move on quickly to overtake. No, overtake is not the right word. To raise up the race for cell manufacturing in Europe.
Maybe to shine light on how you can support this. So you're manufacturing the coating lines on pilot scale level, like up to megawatt-hour level, you said. So how would Mathis and your competences intertwine there, or how would you act in this ecosystem and supporting this? Can you explain that in a couple of sentences?
But first of all, our machines are module built, and we're always looking on the process. What does the process need? And if it means that we need to modify one of our modules, we will do so. We are not sort of saying, okay, this is what we have. No, we're looking on the process, and we're working with the client to understand what they really need in order to perform out their product.
Okay, and then therewith, on the pilot scale, make the experience, do the testing, do the iteration, the optimization, collecting parameters that then prepare them for building this on scale.
Yes, that's we prepare it, or we prepare all the recipes, and then it goes to the gigafactory to perform.
Okay, AraBat, giving raw materials a natural rebirth. As everyone of us know, more than 11 million tons of end-of-life lithium batteries will have been generated in the next years by 2030, an incredible number. But in addition to such number to recycle, there are other problems related to the fact that today battery recycling solutions can't solve the overall problem since they are inefficient. They can recover just 70% of lithium typically on average. Such methods are expensive. According to scientific publication, the typical cost to recycle 1 kilogram of lithium battery recycling in the Western world is over than €5 per kilogram. And such methods are also unsustainable, with kilograms and kilograms of CO2 and other oxides emitted during the recycling. So, what if the solution to batteries, but also to other e-waste, has been right under our feet? That's the question of our startup, of AraBat. And starting from that question, we generated in the last years our innovative solution. So, that is reusing biomasses from fruit, vegetable, and also sea algae to recycle lithium-ion batteries and other waste. It's not a magic trick. It's the secret of the circular economy. More precisely, the technology we developed during the last 3 years corresponds to a revolutionary patented recycling process, a green hydrometallurgical process that includes 3 main stages. The first one, that is the typical mechanical pretreatment, where the battery is discharged, opened, crushed into the so-called black mass. And the second stage of our technological process is the most value-added stage. Our bio-based leaching, this chemical treatment, where we put our black mass into a reactor in contact with water, organic acids like citric acids, with low molarity and concentration, and this homogeneous and heterogeneous mix of biomasses like simple orange peels from the, for example, orange juice production sector, or artichoke leaves from agriculture, and other biomasses that includes reducing sugars and other specific substances that cooperate with the organic acids to lixiviate the black mass and put the raw materials ion into the solution. Our final stage is a selective precipitation stage where we can recover the nickel and manganese and cobalt, and finally the lithium in the form of hydroxides and the latter in the form of carbonate by changing the pH of the leaching solution. That's our process with a very high performance. Just for example, we have up to 99% of leaching efficiency capability, and our current performance rates achieve up to 90-95% of precipitation rates of the all critical raw materials that are strategic resources for our countries and continents. In very summary words, we were born in 2022, and in the years we validated and scaled up our technology from lab to pilot scale. We filed 2 patents, granted 1, and we are expanding our operations and starting the industrialization process. The calls to action: now we are raising funds, the first investment round, to build our own pilot facility to put in Italy, and so to start our orange dream, to make real our orange dream. We are among the most promising startups in our sector, according to Startups Insights. And well, we are the ones who have given a biological dimension to the electrical transition, since the fate of the world may depend on a simple, beautiful orange. Thank you for your attention, and I am here for your questions.
Thank you very much, Raffaele, for the of a really interesting idea. And I see, Dima, you have already a question.
Yes, Raffaele, thank you for the presentation. 2 quick questions. Are the precipitated metal salts battery grade, and have you tested them in battery, like a coin cell, pouch cell, and compared with the reference? How is the performance?
Yeah. The last stage of that of precipitation stage, our raw materials currently, they have, as I mentioned before, good performance rate. More precisely, our products have around 90% of purity rates. So they are ready for production sectors like metallurgy, pharmaceutical, and others. And now we are optimizing these numbers to achieve the battery grade standards, because the battery sector, to close the loop, it requires very, very high purity rates, typically around 95-99%. And the next step is optimizing these last points in terms of purity rates and reusing those to create new battery cathodes. And we are working on that also from since weeks with the US Research Center and other European universities to fill this last gap.
Thank you, Raffaele. Good luck with this. Great job. All the best to you.
And Zainab, you have also a question.
Yes, so I want to say that it's a good idea. Thank you for this. But one question: how you adjust the pH? You said that you are an influence on the pH of some elements, and then it has an influence on the composite of the lithium or the battery that will be used or will be fabricated. So that's the question: how the pH of the elements has an influence, or how you can adjust it. Like, there are some specific tests to be done, or yeah.
Yes. Thank you for your questions. Very interesting point. In our case, our selective precipitation stage is made by changing the pH with salts for nickel and manganese. That is our first precipitation stage. Then we activate another pH changing mechanism thanks to the, for example, ethanol to have cobalt hydroxide, and finally, by capturing CO2 from outside, we can activate the insufflation and then the precipitation of lithium in terms of carbonate. And just two words, this stage is very important to calibrate the pH and maintaining the temperature in a very precise way, because it's very important for the precipitation and the generation of the raw materials in the final form.
Thank you. Thank you so much for your clarification.
Perfect. And so thank you again, Raffaele, for your presentation. Good luck with your startup. We are, of course, from the TraWeBa network, we are always happy to support you. And yes, from the audience, if you have more questions, if you want to get in contact with Raffaele, I posted his LinkedIn profile in the chat. Just connect with him and keep discussing. And with this, it's time to switch over to the next speaker.
Yes. So when that startup will finally be built up and scale, I think we need competences that really understand how to industrialize the processes and really consider every aspect of what it needs to build such a facility. One of those experts is Stefan Keseberg, and with their team at MPC, so Munschek Process Consulting, they're exactly doing this job and having a really sound approach on tackling various processing steps and layouting factories and finding the best efficient solution, basically. But I don't want to present the company here myself, but want to leave Stefan the stage. So Stefan, you want to put up your presentation and explain a little bit about how you plan clean rooms and other things that are process related?
Yes, thank you, Simon. You see my screen?
Yes. That's clearly visible in presentation mode.
Okay, so thanks a lot. And thanks for invitation. So my name is Stefan from Munschek Process Consulting, and we are factory and clean room planners. And we have several projects with battery manufacturer and supplier as well. And so we know the entire supply chain very well. And most companies are facing some kind of paradigm shift because they have to meet high cleanliness requirements. And in our experience, there are many experts in specific areas, in production processes, but these are not considered holistically and do not to take into account the influence factor of clean room operations. And I think that's a big point because we know it from the shop floor. For example, the airlocks are too small and they are not designed for efficient in-feed process, or repackaging and cleanliness area have not been taken into account. And therefore, we have a big facing in the Gigafactory because we have to consider all essential interactions. So we have machines, we have environment, so the clean room itself, the logistics, the material flow, and also the personnel. And the classic solution are cleaning, repackaging, and additional processes. But all of this costs time, money, and efficiency. In addition, many companies in the automotive industry are guided by classic lean principles. And this is where conflict arises. At first glance, cleanliness zones and lean concepts seem to contradict each other. We think only by taking a holistic view and we know the key interactions, we can design processes scalable and can reduce cost for OPEX and CAPEX, for example. And even the best material flow concept is useless if the employees crosses the area and have not regulated processes. And that's a big point. And I have a few insights, for example, the packaging processes. The packaging process is some kind of a black hole because manufacturers demand something from the supplier without knowing what impact this will have on the processes. And why we need packaging processes, we want to avoid contamination and we want to have no particles in the clean room. And the idea is to remove each packaging layer in the dedicated zones. And which dedicated zones do we have? I show you now. So here you can see some kind of an ideal zoning concept. So we have separate workers and equipment in dedicated areas. So when we have a black area, it's a typical normal production without any cleanliness requirements. We have several workers and several forklift, for example, and we have clear separation to prevent cross-contamination. And in some cases, the holistic zoning concept is missing. So we have high operating costs, we have quality problems, and we have cross-contamination between the zones. And without these boundaries, you have to know it's like, it's like looking for a needle in a haystack. So due to many interactions, it often remains unclear where the contamination comes from. So when we have no clear zoning concepts, it's very difficult. And this is just an example for material flow. However, all influence factors like personal flows, maintenance materials, spare parts, cleaning agents, had a big influence on airlock frequencies, on cycle time from the production, and the operational running of the clean room. And when we have a look at the holistic supply chain, it's very important that a clean supply chain must ensure that the battery components meet the agreed cleanliness requirements from the supplier production facility to the battery manufacturing machine. Otherwise, investing in a clean room offers no added value for both sides. And I think that's a big point. And I think this was some kind of insights and a teaser how we can plan processes for factory and for clean rooms. And the result should be smooth factory operations if we consider all subsystems and all interactions in the process. And I think we need European supply chains to protect this, because when we have a delivery from China with a transport route from 4 weeks, it's very critical for the product, for contamination, and the follow-up cost for cleaning can be very massive. So thank you for your time, and I'm here for your questions, and I hope you like the presentation. Thanks.
Yes, certainly I did, and I hope the audience as well. It's really, really impressive that there are so many things that you don't immediately consider, right? And what you just say, contamination is key, especially in battery manufacturing. Maybe you can just explain in a word or a couple of words why. Like, what are you looking for in terms of contamination? Is it like metal particles? What is needed to be taken care of in terms of cleanliness?
First of all, you have to take into account the wood pellet or card box or anything else, and you have to remove this layer before you enter your battery production. And when you don't have a smart packaging concept, you have to clean material, you have to take care, then you don't have contamination in your clean room. That's a big point. And that's a fact that many companies don't know. And the experience is we built a gigafactory without this experience, without to know what about contamination, what about cleaning, for example. When we have a ramp up with a can, we spoke about 30 pallets per day. When we increase in serial production, we talk about 120 pallets per day. So it's a factor from 4. And when we don't have to know what we do when we have a contamination, it's a very increase of cost regarding production downtimes, storage cost, or anything else. And I think that's a big point that very much people don't know and have to take no eye on this.
Yeah, and this is then where you start to search for the needle in the hay when you have a process set up or a factory, a facility where you don't know exactly like who is doing what when and what are the defined processes, that you then really have to search for, okay, where could this contamination come from? And so you're opting, as I understood, for planning this upfront, planning this through, and then also building up the factory with a clear structure in mind, with a clear cleanliness concept, that we have like quality right from the start. And maybe circling back to what those gigafactories are going through, this is also what they are struggling with right now. In general, right? This is a very critical part to really bring the cells up to quality. Because also, we just heard the presentation of Clemens, right? Coding is also key, and having a pristine coding also relies on really clean environments, which are dust-free, for example. And this is where Stefan's competence ties in. So, Stefan, thank you very much for outlining your competences. And if there is any question regarding factory planning and clean rooms, feel free to approach him. And yeah, so...
Yes, thank you very much for the warm introduction. It's true that traditionally graphenes are very difficult. That's something that we actually want to change. So in the next few minutes, I will talk a little bit about 𝗕𝘁𝗁𝗲 and our graphene, which is e-graphene and not just regular graphene, and which we would like to see in the future as a novel conductive additive for European batteries. So the question, I guess, that people ask themselves when they're making batteries, especially also facing the competition from Asia and supply chains and things like this, is how can we make not only batteries like the people from China are doing, but how can we make even better batteries and also support a European value chain? And one thing that we have to look at here is that there is a dilemma, let's say. So I guess you all know, if you're working in this field, that every battery needs conductive additives. And there is the state of the art, which is carbon black. And then there is a performance benchmark material that is used, which is single-walled carbon nanotubes. But the problem really is that carbon black is not so conductive, and you need quite high loadings to achieve a good conductivity in your electrodes. But it's cheap and it's abundant, but it's lacking performance. And on the other hand, you have the single-walled carbon nanotubes, which really excel in terms of electrical conductivity and making your electrode conductive. So you need only very little. But on the other hand, they are super expensive, and basically 90% of the worldwide supply of this material is located in a single production site, and this is not inside the EU. So in between there, we have an opportunity. And I think that our e-graphene perfectly fits in this space. And I will tell you 6 facts about it and hope to spark your interest and see if we can work together in the future. So first of all, in terms of performance, our e-graphenes, as used in conductive additives in various electrodes, show really CNT level performance in terms of conductivity. So in numbers, they are around 50 times more conductive than carbon black. They are also affordable. So our process is quite efficient and also green. So it's mostly water-based. And the E in e-graphene actually stands for electrochemical exfoliation. So it's an electrochemical process. And if you consider the costs in euros per kilowatt hour that you need to achieve a certain conductivity in your electrode, we can actually be 90% cheaper than single-walled carbon nanotubes. It's also easy to use. So what Maximilian said in the beginning is probably was true for his research, but it's a pity that you haven't known, or maybe didn't exist back then. But what we can actually offer is that with our process we can produce graphene that is intrinsically functionalized. So it is easy to process, and we can provide it in drop-in formulations, in dispersion or paste form, in various solvents from water to NMP, or usually whatever the customers require, without any surfactants. So we don't need any binders or surfactants or other additives to stabilize the graphene, and that really makes it very convenient and easy to use. What is also very special about e-graphenes is that in the future, because our production process has a very small footprint, we will be able to modularize and autonomize it. So the plan actually is that even at gigafactory scale, we will be able to produce the material on site or locally. So especially if you are considering that you want to ship around a dispersion or a paste with a few weight % of actual solid material in them, you're shipping around a lot of solvents or water that on the one hand get accumulated in the place where they are used, and on the other hand, they also have to be transported. So this is something that really also makes our process unique in the sense that it is possible to really integrate with the production, or at least produce it locally and significantly reduce supply chain risks and also logistic costs, and of course also emissions that are related to that. So yeah, so in summary, basically, we can say that with 𝗕graphene, we can achieve more energy density in the battery while producing less CO2 or less emissions. We can have safer batteries and lower supply chain risks, and all in all, achieve more performance for less euros per kilowatt hour. It's also interesting to know that beyond the conductive additives, which have been also proven from various customers and partners in various battery chemistries, like both NMC, LFP cathodes, but also various anode materials, graphene has also been proven as an interface material, for example, in solid state and lithium metal batteries, where it really improved cycling stability and energy density because it is really, really thin, and also as a separator material in redox flow batteries and fuel cells. So with that, I think I'm also finished with my 4 minutes, and I would like to thank you for your attention. If you are interested, if you have any application ideas, or you just want to learn more, please feel free to reach out. And yeah, for us, batteries are just the beginning. Thank you very much.
Thank you very much for this interesting overview. And yes, I have a couple of questions, but if there are questions from the audience, then please raise your hand. And but maybe before 𝗕𝘁 can ask this question, I have just a really short one. As I understood it, you have the graphene in the solution, so you have like flakes. Could you maybe comment how big these flakes are and how many layers? Like, is it really monolayer graphene, or with which amount of layers are you working with?
So we are talking about a few layer graphene, which is essentially defined from different norms to be typically less than 5 layers, but could be up to 10 layers, I would say, depending also a little bit on the formulations. But yeah, to get a pure monolayer graphene, I think is really challenging if you start from a graphitic raw material and not build it from scratch, basically. But yeah, what we've seen is that it's also not really necessary to have a pure monolayer graphene for most applications. Yeah.
Thank you. Then 𝗕𝘁, your question.
Martin, thank you for presentation. Just a quick question. Do you also oxidize the graphene? So if I need graphene oxide, do you supply it to your clients or no?
So the electrochemical process that we're doing is in water, so that it can be tuned to introduce also oxidation to various degrees. Typically, we are not interested to oxidize it too much because obviously we want it to be very conductive. And but yeah, the process itself is very flexible in that regard. So if a higher degree of oxidation is needed or certain functional groups, then that's typically also feasible. So the process can be customized without changing the equipment. So it's really the recipe of the electrolyte that is like, yeah, influencing the quality of the material. Yeah.
Okay, thank you very much.
Sure.
Yeah, Simon, please continue.
Yeah, I less have a question than a remark. I recently visited Saxonia, and if you want to know more about this and also about the other battery expedition partners who are on board here, you're also free to check out the videos that are released soon, because yeah, also the visit at Saxonia was really inspiring to see how a startup like grows and defines its business case. So yeah, I just wanted to mention that. So yeah, also thank you for the insights that you provided.
Sure. Yeah, it was great having you for sure. Yeah.
Perfect.